Okay, for what we have in section 1.8, okay, we are looking at operations between functions, and now we have for our functions s of x and t of x. So f of x, that s of x is equal to x minus 1, and we have t of x is equal to 4x plus 3. And if we're looking for s plus t of x, now for what we have in this layout, okay, so you have for s plus t of x, so we're looking at s of x plus t of x. And for s of x plus t of x, now we have with s of x, we have x minus 1. For t of x, I have 4x plus 3. And if I add the terms together, so I have x minus 1 plus 4x plus 3. And combining like terms together, we have x plus 4x will make 5x. And we have negative 1 plus 3, that's going to make plus 2. So we have for this first part, okay, we have for s plus t of x, we have 5x plus 2. Now for s minus t of x, so I'm looking at s of x minus t of x. For s of x, again, I have x minus 1. I have minus t of x, and for t of x, again, I have 4x plus 3. And so 4x plus 3 is going to have the signs changed. So we're going to have x minus 1 minus 4x minus 3. And x minus 4x becomes negative 3x. Negative 1 minus 3 becomes negative 4. Now for s times t of negative 1, okay, and you can do this in either of two ways. Okay, we can say that for s of negative 1, we have is equal to negative 1 minus 1, so this will come out to negative 2. And for t of negative 1, we have 4 times negative 1 plus 3. 4 times negative 1 is negative 4 plus 3. So we have at negative 1. So we have for s times t of negative 1, and we have s of negative 1 times t of negative 1. S of negative 1 I have at negative 2. And t of negative 1 I have at minus 1. Negative 2 times negative 1 comes out to a positive 2. Now another way that you could do this is that if I were to take s times t of x, so I have s of x times t of x, and again s of x I have x minus 1, and t of x I have at 4x plus 3. If I were to distribute, so I have 4x squared, and they have with the outside and inside products combining, have 3x minus 4x, so I have negative x. Negative 1 times 3 becomes negative 3. And on this basis, okay, if I have with s times t of negative 1, so I have 4 times the square of negative 1, and I have minus negative 1, and then I have minus 3. Negative 1 squared is 1 times 4 is 4, and I got plus 1, minus 3, 5 minus 3 also comes out to 2. So either approach is going to work. Now, for what we have in the case of question number 2, okay, we have g of x, we have 4 plus x quantity times the quantity of negative 2 plus x, and we have h of x is equal to 6 plus 2x. Okay, now for g over h of 3, okay, now you can take either approach. Now for, if I have g of 3, okay, so I have 4 plus 3, quantity times the quantity of negative 2 plus 3. 4 plus 3 is 7. Negative 2 plus 3 is going to be at 1. 7 times 1 is 7. And as for what we have in the case of h of 3, okay, for h of 3, okay, we have 6 plus 2 times 3. And so we have 6 plus 6. So that is going to end up at 12. So we have for g over h of 3, so we're going to have g of 3 over h of 3. And so we have for this outcome, we end up at 7/12. All right. And in the case of what we have concerning the values not in the domain of g over h, so we have for g over h of x. So we're looking at g of x over h of x. And again, we have with g of x, so I have 4 plus x quantity times the quantity of negative 2 plus x. And I have all over h of x, so we have 6 plus 2x. And again, just for the restrictions we have for this rational expression, it's going to follow that the denominator cannot be 0 in value. Okay, so if 6 plus 2x cannot be 0, that means that 2x cannot be at negative 6. And so we have, in this particular case, right, we have the x cannot be equal to negative 3. Okay, so in terms of all the values not in the domain of g over h, and we have for this result only negative 3 is not in the domain. Okay, and then we have for the next item. Okay, and we have with question number 3. Okay, it says that suppose that the functions q and r are defined as follows. Okay, and so we have for q of x, okay, we have negative 2x plus 1. R of x, we have 2x squared. And if I take the compositions in this particular case, now for what we have in this particular case, now if I were to put this in terms of going from q of x to q of 1, and likewise going from r of x to r of 1. Okay, so we have with q of 1, okay, we have negative 2 times 1 plus 1, and we have negative 2 plus 1, so q of 1 is equal to negative 1. For r of 1, okay, have okay, so have 2x squared, where x is going to be a 1, and we have 2 times 1, and that is equal to 1. Okay, now in the case of what we have for the first composition, now we have for r composed with q of 1, so we're looking at r of q of 1. And guess what? We have q of 1 is equal to negative 1. So I'm looking at r of negative 1 And in terms of what to do with the negative 1, so we'll operate along the lines of r of x is equal to x squared. And guess what? We have with the input at negative 1 to represent x. So we're going to have, in effect, so we're taking the square of negative 1. And so we have for the first composition, we have the square of negative 1, so that will result as a positive 1. Now, for q of r of 1, which results from taking q composed with r at x is equal to 1. Okay, so we have with r of 1, okay, that is equal to positive 1. So I'm now looking at q of 1. And in terms of what to do with 1, we'll operate along the lines of q of x. So again, we have, so we got q of x is equal to negative 2x plus 1. And in terms of how we're going to follow through, so with 1, replacing x with 1, so we're going to have negative 2. And we have times 1. And we have with the addition of 1, turns out that we have negative 2 plus 1. So q composed with r, whenever x is equal to 1, that result ends up at minus 1. Okay. Now, I'll get into question 4 later on, but I'll tell you what, if we go ahead and look at question 5. Okay, so we have, it says to, in this case, we have for the real valued functions, f of x is equal to the square root of 2x plus 18, and g of x is equal to x minus 14. It says to find the composition f composed with g and specify its domain using interval notation. Okay, so we have with f composed with g of x. Okay, so we're going to have f of g of x. Okay. So now with g of x as the input function, so I have f of x minus 4. Okay, now with x minus 4, okay, this is a linear statement, so we don't have any restriction so far. So the input has no restriction, and the domain of this composition is going to be looking at combining the restrictions, if any, between the input and the output. Okay, and in terms of how to follow through with x minus 4, okay, again, we have with operating along the lines of f of x is equal to the square root of 2x plus 18. You have applying the treatment, so we have the input not at x but at x minus 4. Okay. And so we have in following through. Okay, so you have so you got the square root. Okay, so you have 2x minus 8 followed by the addition of 18. So we have, in the case of the composition, okay, so we'll end up with 2x plus 10. Okay, so for f composed with g of x, okay, this is going to be your final answer, whereupon we have the square root of 2x plus 10. Okay, now in terms of the output, now we have the restriction, since we have a square root function. Okay, 2x plus 10 cannot be negative. Now it can be 0 and it can be positive. So we can say we have 2x plus 10 is greater than or equal to 0, and we have 2x is greater than or equal to negative 10. And if I divide by 2, now we have with the inequality that defines the domain, we have x is greater than or equal to negative 5. Okay, so we have upon combining the restrictions, it's going to follow that with the domain. Okay, we have all values of x greater than or equal to negative 5. So we have, in utilizing interval notation, we have a bracket around negative 5, and all other values, okay, will be greater than 5. Okay, so that would be the interval solution that defines the domain. Okay,